Volume of a ball is increasing. I'm going to model the problem. Try to draw my best three-dimensional shape. Right, you point out all of the things I'm bad at. Thank you. Okay, the volume is increasing. It's getting larger. Somebody tell me, what are some of the things that are changing in this problem? Circumference, area, volume, surface area. Did you say pi? Time. Okay, thank you. Time. Time is changing. And they are all changing with respect to time, which is what makes this so beautiful. That's why we do the derivative with respect to time. But first, we need an equation. Somebody want to give me the equation? Good. 4 over 3 pi r cubed. That's the volume of a sphere. What are some of the things we know? Okay, I'm sorry. Yeah, that's a mislabel there. But yes, so V prime is what? 10. And we know the current volume is 100. What's our unknown? D prime. Shoot. Why is that a problem? We don't even have a D in the problem. But we got an R. Are you sure? How about this? We do know that 2 times the radius is equal to the diameter, correct? And so we do know that the radius is equal to 1/2 the diameter. So what could I do with that 1/2 D? Plug it in for R. And so I'm going to come up with a new equation. The equation I'm going to come up with does not have R in it. It's going to have D in it. I mean, there's no reason why we can't. I mean, they wrote a formula for volume that has radius. They very easily could have said, well, we're going to write a formula for volume that has D, diameter. And they just chose to use R. So we're going to use D. So I'm going to do a little scratch work here. We got 4 over 3 times pi times 1 over 2 D cubed. Don't take the derivative like that because you're going to have to use the chain rule, aren't you? Just multiply it out. Make life easier on yourself. So I got 4 over 3 pi times what? What's 1/2 to the third power? 1 over 8 times d to the third. So this becomes 4 pi over 24 d cubed. 4 over 24 is... So my final answer for the volume formula is volume is pi over 6 d cubed. So all I did is wrote a new formula. This is in terms of R. This is in terms of D. I want a formula in terms of D because I'm looking for D prime. Yeah? Let's take the derivative with respect to time of V is equal to pi over 6 D cubed. What's the derivative of volume with respect to time? V prime equals. Good, yeah, dump the 3 in front, get pi over 2. D squared, D prime, thank you. What is V prime? 10 equals pi over 2. D squared, D prime. Shoot, I don't know the current diameter, do I? Could I find the current diameter? How? I know the current volume is 100. Will that allow me to solve for D? Yeah, looks like we got some more work to do. I'm going to solve that here. 100 is equal to pi over 6 d cubed. That will allow me to solve for the diameter. Multiply both sides by 6 over pi. (600 over pi is d cubed. Take the cubed root of that guy. 600 divided by pi. Cubed root. Raise it to the 1/3 power. That's how I like to do it. 5.76. 5.758. So now what do I do with that? Plug it in. (10 equals pi over 2. 5.758 squared. D prime. Now we just, do some basic algebra. 10 times 2. I'm going to divide by the pi. I'm going to divide by 5.758 squared. And I get 0.192. 0.192 what? Centimeters per second. Very good. Excellent. Okay, this is the key. What is it that we are measuring? We're measuring the rate at which the diameter is changing, right? Diameter is a one-dimensional measurement. Area is two-dimensional, so it'll be squared. Volume is three-dimensional, so it'll be cubed. So it's a one-dimensional measurement. So we just leave it there. You better answer that. Well, that's okay. Yeah. Let's switch it up. And I want you guys to know, again, I've looked at so many problems from the AP exam over the years. I'm showing you problems. These are all ones that could pop up. This is one of the latest ones I saw, and it's a great problem. Airplane is traveling east at 600 miles an hour. Another is traveling north at 750 miles an hour. If they left the airport at the same time, how fast is the rate of their distance apart increasing after 2 hours? 12. Very good. It just sounds impossible, doesn't it? I mean, it truly sounds impossible. But the fact is that you're brilliant math students, and we're going to be able to do it, and we're going to make it look easy. I love the 4 boxes. Studies show students learn better. You do what you want, but I got to figure out a way to teach. This is the way I use it. Here we got the airport. We got one traveling east. We got one traveling north. So one going east is going at 600 miles per hour. One going north is 750 miles per hour. Oh boy. Very good. I do try to set you up in previous classes to help you out with this class. So yes, should remind you a little bit. Can somebody tell me something, anything? I've got a picture. I need an equation. Pythagorean theorem. How about we do this? E for east, N for north, D for distance. You guys roll with that? So what's my formula? Sweet. What do I currently know? I don't know E. I know E prime. What is E prime? 600. What is N prime? 750. Because we're given the rate, we're given the velocity, we're not given the actual distance. I wonder, could I figure out the distance? For example, if it's traveling at 600 miles an hour for how many hours? 2 hours, what would be the distance? Oh, so we do know E. E is 1200. I wonder if I could figure out N. 1500. Wow, you guys are smart. What am I trying to find? Okay, so if we say every variable, we're bound to get it right. I heard D squared, I heard D prime, and I heard D. What do we want to find? How fast is their distance apart increasing? That's D prime. Let's take the derivative with respect to time. Yes, thank you for asking, okay? Because somebody else has the same question then. All right, there you go. All right, so I jog at 5 miles an hour. I've been jogging for 3 hours. How many miles will I travel? 5 miles every hour, 3 hours. 15. Same thing. It's been going for 2 hours. 2 hours, 750 miles an hour. We good? Got it. You guys remember this? This part of the setup is from your trig problems where we had a ship traveling at a bearing, another ship traveling at a bearing. We had the law of cosines. Yeah, yep. I mean, we try to be intentional about this stuff. Everybody start clapping. Hey, Sledgy. How we doing? Thank you. Derivative with respect to time. What do you got? Thank you, Riley. 2nn prime plus 2e prime equals. Sweet. That's totally legitimate, okay? So I've got 2 times n is 1500, and n prime is 750. 2 times 1200 equals. Shoot. Oh, I got 2 unknowns. Use the Pythagorean theorem. Thank you. Do it. What do I do? Yep, 1200 squared plus 1500 squared. And I'm going to take the square root of that guy, right? And I get 1920.937. No, I did the Pythagorean theorem. So this was this guy is 1500. This is 1200. So I did 1200 squared plus 1500 squared is that squared. I don't need to. Those are rates. I used the Pythagorean theorem for the distances. Okay, so here we go. I've got I'm at 2 times 1500 times 750 plus 2 times 1200 times 600 divide by 2, divide by 1920.937. 960.468. What? Miles per hour. I don't know if I know what you're asking. Can we try one more time? So I got 1920 by looking at n, not n prime. I used n. N is 1500. Squared that. I didn't use e prime. I used e. E was 1200. Squared that. Add them together, square root. Pythagorean theorem. You saw, okay, are you saying you saw the same number come up twice? Okay, that was just chance. All right. Okay, you're doing good. We got to continue to move. A ladder 12 feet long is sliding down the side of a building. The base of the ladder is moving at a rate of 1 feet per second away from the wall. How fast is the top of the ladder falling when the base of the ladder is 10 feet from the base? There we go. We got a building. Okay. So I'm going to try. I'm going to try to give you guys a way to think through this. I mean, I know we do examples together, and after a while, you start to just kind of follow the examples we do in class. But let's try to think on our own for a second. As I approach a problem I've never done before, this is immediately what I try to think through. What is changing? Does the length of the ladder change? No, it does not change. Because the length of the ladder does not change, I could put the length of the ladder, which is 12, right there. Okay? So this is changing, right? So I could call this maybe like, say, y. So y is changing, and then we'll call this horizontal distance x. That's changing. So if it's changing, I need a variable. If it's not changing, put the constant in. What's the equation that relates these together? What do we know? X prime. Why, Riley? Can you say more? Yeah, this is happening at 1. That's what it says, right? So x prime is 1. What else do we know? So which variable is that? X is 10. That looks like all the information we're given right now. What are we trying to find? Y prime. Would you agree that we're probably going to have to figure out y? How do you know we're going to have to figure out y? Because when we take the derivative, we come up with 2y prime. So you can see you're going to have to know the y value. Is there enough information here to come up with y? Yeah, all we do is we just take 10, plug in for x. We get 100 plus y squared is 144, or y squared is 44, so y is 2 roots of 11. Right? So that's a good way to, again, you kind of want to keep an eye ahead on what's going on. So now I just got to take the derivative with respect to time. And that's easy. Of x squared plus y squared is equal to 144. I mean, the derivative is the easiest thing in the whole problem. We used to think that derivatives were difficult. Now we're like, please give me a derivative any day. What's the derivative? 2x x prime plus 2y prime equals 0. Now, what do you think the mistake people make? Yeah, they take the derivative, they put 144 there. It's just like, oh, it's 144. Remember, the derivative of a constant is 0. So that was a mistake that did happen a couple times in the last test. What's that? Because, very good. So Grace is thinking this right now. She's thinking, boy, Mr. Gens, I remember we had x squared plus y squared is equal to 9. That was a circle. And when you took the derivative, you did 2x plus 2y, y prime is equal to 0. But now, all of a sudden, you're throwing an x prime on there. Why the heck are you changing what you're doing? Who could tell me? Because it's derivative with respect to time, not x. See the difference? Because you got that t variable right here, that tells you got to attach the x prime to the y prime. If it was derivative with respect to x, then it would just be 2x plus 2y prime. Got it? Excellent, excellent question. High-level question. I should get a raise. All right, here we go. Now what? Okay, so 2 times 10 times 1 plus 2 times 2 roots of 11 times y prime is equal to 0. So 20 plus y prime 4 roots of 11 is equal to 0. So y prime is equal to negative 20 over 4 roots of 11. Equals negative 5 over the root of 11. Or negative 5 roots of 11 over 11. Here's the deal, guys. The AP exam, actually, they will allow you to leave it so it's just negative 20 over 4. You don't even have to simplify it to negative 5. Not my class. You want to express it like this, simplify the radical. I will not ask for it in exact form. Most of you will simply just turn it into a decimal. And so you do negative 5 root of 11 divided by 11. And we get negative 1.507 what? Feet per second. Now, my question to you is this. Why in the heck is it negative? Oh, interesting. Now, here's what I haven't come to reconcile yet, okay, is that it looks like if it's moving backward, the x prime should be negative as well, doesn't it? But I could have just put it on the other side, right? Yeah, doesn't really matter. Yeah. Right here? Oh, thank you for asking. Okay, so you know x is 10, correct? So I've got 100 plus y squared is equal to 144. Got it now? Okay, good work. All right, you're almost there. We really need to get through these two more. Okay. We'll finish off the related rates notes tomorrow. I don't know. Are we talking snow days already? Wow. Thank you. Appreciate your compliment. Water is being poured into a cylindrical container at a rate of 6 cubic centimeters per second. If the radius of the container is 3 and the height is 6, at what rate is the height increasing when there is 24 cubic centimeters of water? I know, it hurts your head to even look at it, right? So let's slow down. Let's divide in the 4 pieces, and let's start right at the basics. What's changing? What's not changing? Okay, so you know that h prime is a variable in this. Agreed? And you said that the volume is changing, right? So we know there's a certain volume. Looks like we're given v prime. You can. Go ahead. Whatever makes you happy. Okay, so what's not changing? What's remaining constant? The radius of the water never changes, right? Now, here's what's important to consider as well, is that does the size of the cylinder change? Does the height of the water change? And do you notice that the radius of the water is always the same as, the radius of the container, right? Does it tell us the radius of the container? 3. It's always 3, right? So I don't need R up here, do I? Because it doesn't change. Okay, what are some of the things that I know? The height of the cylinder is 6, but is the height of the water 6? See the difference? Do we care about the height of the cylinder? No, we don't. Try to mislead you. Okay. What do we know else? I'm going to get rid of that guy because I don't like that. Radius is 3. Okay, so V prime is 6. And V is 24. What are we trying to determine? H prime is what we're trying to determine. What's my formula for volume of a cylinder? Pi r squared times H. Uh-oh, I have 2 variables. And they're being multiplied, so I have to use the product rule. Say it. Why? Because it's constant. Exactly. You see it and you're like, you know what? I'd like to get rid of one of those. In this situation, you can, because the radius is not changing. So just plug it in right away. So therefore, the volume becomes 9 pi times h. Right, so much better, right? So we take the derivative with respect to time of volume equals 9 pi h. What's the derivative of v? V prime. Okay, thank you. Yes, you're 100% right. Good job. What's the derivative of 9 pi h? Good. What's v prime? So 2 over 3 pi is equal to h prime, right? Did we even need to know the current height? Current height doesn't matter. So therefore, h prime is equal to 2 over 3 pi what? What's my label? Awesome. All right, last one for today. Okay, we'll finish out the others tomorrow. Boyle's law. Anybody know Boyle's law? Boyle's law states that if the temperature of a gas remains constant, the pressure P and V of the gas satisfy the equation P times V is C. Okay? Where C is constant. So if the volume is decreasing at a rate of 10 cubic inches per second, how fast is the pressure increasing when the pressure is 100 pounds per inch squared and the volume is 20 cubic inches? Makes your head hurt, right? I get it. Sometimes modeling the problem, okay, sometimes modeling the problem looks a little bit different than drawing a picture. We know this. Pressure times volume equals a constant. Again, I told you, best piece of advice somebody ever gave me in math class said, when you don't know how to do the problem, just do the problem. Okay? What's the current pressure? It says that the current pressure is increasing, right? So do we know the current pressure? No, we don't. Okay? Do we know the current volume? We know the current volume. The current volume is 20. So I'm sorry. Yes. Yep. Sorry, I read that incorrectly. I was looking at is increasing at a rate. Very good. So the pressure is 100 times what's the volume? 20. That's equal to 2,000. So here's what's happening. As the pressure changes, suppose the pressure dropped to 50. Anybody know what the volume would go to? 40. See, as the pressure drops, the volume goes up. Suppose the pressure dropped to 20. The volume would be 100. See? These two always multiply to 2,000. This remains constant. That's Boyle's law. As this drops, this goes up and the other way around. See that? So therefore, we have a formula. Pressure times volume is equal to 2,000. Is the pressure changing? Yep, so we have P prime. What is the current pressure? 100. Is the volume changing? Yes. What's the current volume? 20. Do you know P prime or V prime? What's V prime? Decreasing at a rate of 10 cubic inches per second. So we're going to go negative 10 for V prime. What's the problem asking for? Yeah, how fast is the pressure increasing? So exactly, we're looking for P prime in this situation. So I'm going to take the derivative with respect to time of PV equals 2,000. Now, we definitely have two variables here, don't we? And they're both changing, so you can't plug something in and just get rid of it, can you? So we have to use what? Product rule. So what's the derivative of P? P prime times V plus V prime times P. What's the derivative of 2,000? 0. So earlier, Rowan caught that I didn't catch that we knew the current pressure. I knew that in the problem, doesn't matter that it's 2,000. The derivative ends up to be 0. So, but you can see we would have ended up needing it anyway, but that's kind of where my mind was going. So, so good catch there. What is P prime? What is V? We have 20 P prime plus V prime times P. Negative 1,000 is equal to 0. So 20 P prime is equal to 1,000. Divide by 20. I get P prime is equal to 50. So what that tells us is at what rate is the pressure increasing? 50. And we go pounds per inch squared, okay? And then it's, what's our time? Per second. And so you put the second in the denominator with the inches squared. Yeah, that's a real label right there. All right. Pull out your set of problems, and I'll show you a bunch that you could start working at. Okay. What? I got to look at our schedule right now. We're testing college algebra next week, Wednesday. I got to see where we're at here. We got 1, 2, 3, 4, 5, 6. Those are all ones that are good to do right now. Okay. I would do 7. Don't do 8 yet. I would do 9. I would do 10. I would do 11. I would do 12. I would like to tell you, but it really wouldn't be that helpful to you right now. Finally, if you flip it over, I would also encourage you to try 16 right now. Okay. I will show you. I'll show you a couple other problems tomorrow that will help you kind of finish off some of these. I'll tell you the rest that you really need to choose from. But, you know, I want to I want to let you guys know that over the years, you know, these level 1 problems, they go really well for most of the students. When you get into the level 2, remember where we had to solve for diameter? Our first example today, we had to say, you know, radius was equal to 1/2 diameter and plug it in. Just about every problem I circled up here is like that. And so you're going to need to really focus and be careful with your mathematics, okay? Check that answer key. If you're getting stuff wrong, come and see me. Let's talk about it, okay? These are not easy.